Today we're looking at LeetCode Problem 83, remove duplicates from sorted list. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. Example, we have a linked list with 1, 1, 2, 3, 3 and null. And we can see once it's been processed it goes to 1, 2, 3 and null. The approach that we're going to be taking is the in-place linked list modification using a single pass. It has a time complexity of O of n and a space complexity of O of 1, and it's the optimal solution to this problem. Now let's walk through an example. We have the nodes 1, 1, 2, 3, 3 and null. Step 1. We want to create a current pointer and start it at the head. Current is equal to head, so let's put current pointer here. And step 2, we want to loop over each node while current and current.next is not null, applying the following logic. So if current.val, which we can see is 1, equals current.next.val, which we can also see equals 1, we need to set current.next equal to current.next.next. So let's update this, and we'll check if current.val, which is 1, equals current.next.next.val, which we can see is equal to 2. They're not equal, so we'll set current equal to current.next. Then again we check if current.val, which is 2, equals current.next.val, which we can see is 3, so that's not true. We set current equal to current.next, so we'll update the current pointer, pointing at 3. And then we need to check if current.val equals current.next.val. Current.next.val is 3, 3 does equal 3, so set current.next equal to current.next.next. So current.next is now equal to null, so break out of the while loop. And then finally, step 3, return head. Thank you very much for watching, it's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode Problem 83, remove duplicates from sorted list in Java. Given the head of a sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. And we're given two examples. Example 1, we're given nodes 1, 1 and 2. Once it's been processed, we then just got nodes 1 and 2. The 1 duplicate has been removed. Example 2. We're given 1, 1, 2, 3 and 3. Once it's been processed, we've then got 1, 2 and 3. We can see that this 1 has been removed and this 3 has been removed. So in terms of edge cases, there's 3 that come to mind. The first one is that we are given an empty linked list. So head is going to equal null. So this is a edge case that our solution is going to need to be able to cover. The second edge case would be where every node has the same value. For example, we could have 3 nodes all equal to 1. So it'd be 1, 1, 1. In that scenario, our output is going to need to be a single node of value 1. And the final edge case that I can think of would be where we are given a linked list where there's no duplication whatsoever. And in that scenario, we want to return basically what was input as the output. There'll be no change or modification to the linked list. Now let's get into it. So the first thing I'm going to do is I'm going to declare a list node, call it current. And this is going to track our current position in the linked list. So we'll set it equal to head because we obviously start at head. And then we'll iterate over the linked list. So while current doesn't equal null and current.next doesn't equal null, we want to check if current.val equals current.next.val. If this is true, it means that we have a duplicate, obviously because the linked list is sorted. So we want to then set current current.next equal to current.next, skipping out the duplicate. Else, if there isn't a duplicate, we just want to move our current pointer to the next node in the linked list. So we'll say current equals current.next. And once this while loop breaks, so either current.next is null or current is null, we've come to the end of the linked list, and basically we just want to return the head of the modified linked list. So let's run that, see if it runs. It does, brilliant. Let's submit it and see if it passes all of the tests. It does. According to this thing, it says that it beats 100% in terms of runtime, and it beats 85.21% in terms of memory. The runtime complexity of this solution is O of n, because it has to go over every single node to check for duplicates, and the space complexity is O of 1 constant. It doesn't change no matter how big or small the linked list is, because it just basically uses current as the memory. And that's the solution. Well, thank you very much for watching. I hope that's clarified the solution for you. If you like the video, please leave a like, and if you could click subscribe, that would massively help me out. Thank you for watching, and good luck with your coding.